Good morning, all. We are going to discuss about probability through probability through axioms. I mean to say axiomatic definition of a probability, right? So let us say that event A is present, then the probability of event A, which is P of A, is the real number. The number if you are assigning to P of A is a real number, right? So which satisfies the following axioms. Right. So axiom 1 says, what is the axiom 1? According to axiom 1, what axiom 1 says, P of A must be greater than or equal to 0. That is, the probability of event A, the probability of event A is always a non-negative real number. This is the axiom 1, right? So axiom 2 says always it is a non-negative quantity, we can say, right? So axiom 2, when I say axiom 2, so P of S is equals to 1. What is S here? S is a total sample space. I mean to say the S, if you observe, this is the total sample space of an event, right? So P of S is equals to 1. That is, the sample space itself is an, we are considered as an event, right? So since it has all, it is encompassing all the events which are present on a sample space. So that means what it should have, what it should have, it should have highest probability. So which consists of all the events which are present on a sample space. It should have highest probability. What is the highest probability that you can say? Which is equals to 1. That is unity. Right. So that is what axiom 2 says. Now come to axiom 3. What axiom 3 states. Right. So according to axiom 3, if a sample space S has, if a sample space, S stands for sample space, S has n elements. What are those n elements? A1, comma A2, comma A3, and so on up to A capital N. Right? Such that where n may be infinite even, if all the events are mutually exclusive. So these are mutually exclusive. So when I say mutually exclusive, we can say am intersecting an is equals to pi, where m is not equal to n. So how m and n varies where m is varied from 1, 2, 3 and so on capital M, and n is varied from 1, 2, 3 and so on capital N, right? So this m and n are varying such that am intersecting an is equals to pi, where m is not equal to n. I mean to say a1 intersecting a2 is equals to pi. Mean to say a1 comma a2, all these are mutually exclusive. This a1 comma a2 comma a3 and so on an, all these are mutually exclusive. So this condition satisfies. Now if this is the situation, now the probability of you know sorry the probability of union n is equals to 1 to capital N, a small n. So what is the meaning of this? Let us decompose, or you bring the union outside of this, right? So apply the probability to all the mutually exclusive events. How can I write? N is equals to 1 to capital N. So P of a small n, sorry, a small n you can write, right? So this you can write, right? Now, if you decompose this by varying n here, so what you are going to get? P of a1 union, P of a2 union, P of a3 union, and so on up to union P of a capital N, right? So this is what the now sometimes this union can also be represented with the plus symbol, right? So if I decompose this and write P of A1 plus P of A2 plus and so on up to plus P of A capital N. So this is what P of union n is equals to 1 to capital N, A small n. This can also be. This is what axiom 3. Right? So axiom 3. So when I say axiomatic definition of a probability, that probability should follow these three axiomatic definitions. What is that? So first is P of A must be greater than or equal to 0, first axiom. And second one is axiom 2, P of S is equals to 1. According to axiom 3, this condition must be satisfied. Thank you all.